Okay, so welcome everybody. This is the 7th in a series of end-to-end machine learning. I'm going to back up the slide here real quick. We turn on recording after we do introduction, so anybody that doesn't want to be on the YouTube video can do that. And we'll jump right into it. Today, one thing I do want to mention is we are going to be sending out a link to a 2024 survey for OMLDS, Orlando Machine Learning and Data Scientists. We do this yearly just to get some feedback from all our members as to what topics and what types of things we would like to try and cover during the year. So we'll be sending that out via our Discord channel and posted on the Meetup group as well.
It's already posted there.
Oh, it's already posted there. Thank you, Ricardo.
It's already posted, yeah.
Great.
But maybe for the participants in this session, maybe we can post it in the chat too.
I will. Yes, let's do that. I'll do that right now. Coming into the chat. So here's the survey link. So you're welcome to participate in that. And then I'm going to post a whole nother slew of links here in chat that are all related to the Meetup group, our YouTube channel, the Discord channel, and then the GitHub and the Google Drive links that are associated with this machine learning series. So all of those are about to pop into chat as well. So there we go. And that makes it easy for anybody that would like to follow those links. But we do ask if you have just a few minutes. It's like a 2-minute survey just on what topics in machine learning and related areas that you might like to see in the coming year from Orlando Machine Learning Data Set. These links here on our end-to-end machine learning challenge, part of these are in the links I just posted in chat. Also, these are associated with this series that we are doing right now. And if you haven't had them in the past, you can go ahead and see them here and grab them out of the chat session as well. We are following a model called the CRISP ML, which is it's actually of European origin, but it's kind of a standards, but it follows kind of a project management structure for machine learning. It was originally based off of a data management structure that's very similar. There's, I think, just one more step added into the ML flow that's here. And at this point in the series, we are down in this model evaluation and engineering section. But in the model evaluation, we're going to be focused. This session is on AutoML and PyCaret in particular. And at that point, I think I need to hand this over to Ricardo. Do you want me to just click through these slides for you, and then I'll hand over for you to do the rest of the presentation?
All right. So again, welcome. Okay, and if you are a new member, I'm glad that you spare some time, to be with us. So if you can go back to the previous slide, yeah.
Yep, sure.
We are now in the build, phase of the model. We are tackling what is called the Kaggle credit fraud transaction data set. That's the one that we chose, and we already have been through more or less, the data understanding, business understanding, data preparation. And now we are doing the model building and model evaluation. So in our previous session last year, we did a baseline model because this is a classification model, if the transaction is fraudulent or not, right? A binary, outcome. We did a baseline using what is called a logistic regression, the logistic regression algorithm. And that's a baseline because we know that other models are going to be more powerful in giving us a better, better prediction, when new data comes in. So that's why one of the frameworks that is out there and is open source is what is called PyCaret. Basically what it does, you can go to the next slide, Ron. No. Okay. So PyCaret, what it does is that it uses the foundational, functions of scikit-learn, and then wraps it up in different, wrappers or class functions so that it's easier for the regular, data machine learning practitioner, to develop a more comprehensive modeling strategy. Okay, the library is open source, is a low code. Okay, I'm using the demo that I'm just using a couple of functions, to run different algorithms at the same time, evaluating them. You can compare the models. You can hyperparameter tune the model. You can do stacks, ensembling, combine different models, etc. So it's very comprehensive, the framework, the PyCaret. And as I said, it's built on top of scikit-learn. So if you know a little bit more, a little bit about scikit-learn, you already know, you by osmosis, you already know PyCaret. So for now, PyCaret is in the third version, PyCaret 3.0, and it has different, universes. Let's call it that way. Different universes for supervised learning. It can do all kinds of regression, classification, and also they have kind of a prototype for handling time series when you have, days and times as a sequence in your data. And also they have some functions for clustering. But today we're going to be just focusing on the classification part, because that's where our model, it's about. Okay, it's about classifying fraudulent transactions, identifying fraudulent transactions within a huge simulated database. Okay, so the next one, Ron. Okay, so let's do this.
Okay, so I'll stop sharing and turn that over to you.
Sure.
Okay, you can share.
And anytime that you have any questions, you can post that in the chat, or just raise your hand if you want to speak. Okay. All right. So we talk a little bit about PyCaret. This is the link, the main link for the documentation of PyCaret. Everything that PyCaret does or is going to do eventually in the future is here. So let me see if I can post that in the chat, just in case. Okay, where is my menu? Hello, menu. It doesn't want to. Okay, so anyway, it's in the slides. Okay,
I got
so
it. I got it. I'll post it for you.
If you can help me there, Ron, because the submenu doesn't want to show up. Okay,
yep,
anyway.
No problem.
So as I said, PyCaret, right? We're in 3.0. It has been in development for quite, a couple of years, and the goal here is to facilitate people that are into machine learning development, try to facilitate all those steps that you have to do, to get your model running, and also to do the evaluation and to do, the other things that come within the modeling phase, hyperparameter tuning, etc. One of the things that we're going to be focusing, as I said, was on the classification, right? Because this is a classification problem. So let me, here we go. Okay, I had the chat here. Okay, good. So let me show you the script that I assembled, and we're going to be running it to a certain extent, because some of these functions, especially the hyperparameter tuning, it takes a long time. So I'll try, to minimize the time maximize the time that we have with some of the main functions that you're going to see. Okay, so this is I'm using VS Code, okay, or you can use any IDE of your choice. You can use PyCharm, you can use Jupyter Notebooks, etc. I'm using VS Code because that's that's how I roll. Okay, So we're going to import some of the libraries. And some of the libraries, if you have been acquainted with Python, some of the libraries are the, what we call the usual suspects, right? We're going to import OS for some operating systems functions, handy functions, pandas, okay, for data frame manipulation, the NumPy, which Panda relies on NumPy, that's the mathematical Pi, then Matplotlib, our graphics library, Seaborn, which is a wrapper on top of Matplotlib that, we'll use it for more of the confusion matrix because I like it better than what PyCaret does. So those are the usual suspects. The one that we're adding is the PyCaret libraries. In the previous versions of PyCaret, you could import the modules right from the PyCaret. For example, if you wanted to do classification, just import classification. Here they change the strategy. I don't know why, okay? And it's not, for me, it's not the best strategy, but this is my own opinion. That you have to import everything from the classification module PyCaret, which is something that maybe it can overburden your computer if you have if you are not good in the memory department, okay? But that's how I got it to work, and then filter some warnings. So let's run this, right? All these imports, cross fingers, right? Always. Yeah, but it should work. I tried it many times, this morning, so let's make sure that everything is running. Okay, so now we have import all the libraries that basically we need to run PyCaret. So now what we're going to do is read the training data set that we have been working in the previous sessions. This one is the one that is already clean. It doesn't have any missing values. Everything is numeric, okay, for those algorithms that only accept numeric data. So everything is in order for that data set to be ingested into those algorithms. So let me read it, okay? And this is, a snapshot of what the database, the training data set, looks like. All right, we have around 648,000 rows observations. That's about half of the original data set. Okay, eventually, when you're doing this, to get the final model, you should run it in the whole data set, but it's going to take some time because it's around 1.2 million transactions. Here, it's just half, which gives us a good idea of what the best models should be. Then, to make sure that we have our data in the right format, right? We do the info, object, and as you can see in the text editor, you can see all the variables that we're going to be using. Okay, and also we have, remember, run the distance variable feature. We have it there too. We didn't get rid of it. Okay, because Ron was the one that
if you're new,
explained.
Yeah, if you're new to the series, that was in one of the prior sessions where we went down the path of calculating a distance based on some of the address information that's presented in the data.
Exactly, and the hypothesis was that if you have a transaction that is more distant from your home customer than others, that could influence, right, the fraudulent probability. We found out that it was not the case, but we'll let the algorithm deal with it. Okay, so now we're going to do the same thing but for the test data. And remember, in the modeling process, we're going to be using the training data set for modeling. Okay, the test data is going to be used as new data. So we're going to confirm if our metrics in the training data set are as good as in the test data set, right? Because if not, then we have a problem, what is called a problem of overfitting. that our model is not generalizing, good enough. Okay, so that's the only thing that we're going to do with a test data set is just, do the predictions and then check if our metrics are not that far, from the training data set. Let's check also the info, right? The test data set, and we have the same, the same manipulations, features, information, and that's vital because the training and the test data should be the same. Okay, so now we are ready to, give the training, use the training data set in PyCaret to develop, all kinds of models. All right. So the first thing that PyCaret needs is that you have to configure what is called a setup, the setup parameters for building these algorithms. So in this, in the documents, this is the setup, and you can see it's kind of dense, because it has all kinds of options that you may use or not use to configure your algorithm. Okay, so for example, let's go back to the script. Okay, this is more like a very simple script, but you can do other kinds of stuff. So for example, you have to define what data are going to use, right? And we are going to use the training data set, the training underscore DF. Then we have to define a target. Which variable of the ones that are in training data set is the target? And the target is defined as fraud, is the indicator. 0 is no fraud, and 1 is fraudulent, right? Then we're going to specify the training size. So how much of the training data set we want for training, and the rest is going to be used internally in the algorithm for validation, right? So we get kind of a cross-validation that we, split that training set, but the chunks are going to be the same size. So in this case, we're going to assign that training size parameter as 0.8. In other words, we're going to use for all those cross-validation sets, we're going to use 80% of the data. And 20% is going to be kind of the validation part. Okay, so we don't, overfit. All right. Then there's another parameter that says data split stratify. When you stratify your sample of the data set, what you're trying to do is that you want the distribution of the response of the output variable, you want it the same. And in this particular case, it's very important because this class, the class of the response, there is fraud, right? Okay, let me put it here. Is fraud. If you do a value count, you will see that most of the observations are grouped in one, outcome, in the 0 outcome, the one that doesn't are fraudulent. So the fraudulent transaction is just a very small part of the outcome of the response. So in order for the algorithm to work better, we want the training and test set, okay, or the validation set, we want it equally distributed. In other words, equal percentage of fraudulent transactions versus non-fraudulent transactions. And that's what this data split stratify does. If you don't, if you set it to false, then it won't do that, okay? In the pre-process, we're going to put a false. There's some pre-processing functions that you can do within PyCaret. For example, normalize the data, encoding, etc. We already did that already. So our data set already has that pre-processing that PyCaret doesn't need to, to do. Then in the cross-validation strategy, we're going to use 10 folds, right? In other words, 10 chunks of the same data set, but with different selection of observations between the training, that 80% training size, and then the 20% validation. All right. So if you can see any diagram in your, in visualizing, You're going to have 80% and 20%. Then another 80% from different observations, and then 20% from different observations. So we are going to shuffle a little bit more the data set so you don't have that selection bias. So we're going to do stratified k-fold, and the fold is going to be 10 because this is a pretty sizable data set, so we can do the 10. Sometimes when the data set is small, we should do maybe 5 or even 3. Then, do we want to normalize the predictors? You have to say true. This is going to be important more for the linear regression or logistic regression parameters or algorithms that use distance, as some kind of measure to get, a prediction. For the tree base, you don't need this. But because we have different types of algorithms, it's always a good practice to set these normalized predictors to true, so that the ranges doesn't affect, okay, the inputs of that feature within the algorithm. All right. Then, lastly, for the experiment, this is, PyCaret. When you do a setup, you are really configuring what is called an experiment, right? So for this experiment, we're going to say that the end jobs, the parallel, indication is going to be -1. So we're going to use all the cores that we have in your machine. If your machine has 6 cores, they use 6 cores, 8 cores, 10 cores, and so forth. The session ID is equal to the random number. Okay, so the session ID is a number that you're going to use for reproducibility purposes. So if you have the same number, it's going to do at least the same allocation, the same folding that we're going to use for each of the experiments. Okay, in this case, it's just 1, 2, 3. Then this one is really important, and you're not going to see it here, but we're going to see it in the next session. Because the next session, we're going to talk a little bit about another framework that is called MLflow. All right, and MLflow is kind of a versioning, and also it helps in the deployment of the model of the models that you're going to select. So if you say log experiment equal true, that means that it's going to create the folders and the information that MLflow needs then, okay, to read it and then to try to make sense of what was the algorithms that were run. All right, so you get that basically for free, okay? Because if you do it via scikit-learn, for example, then you have to go to MLflow and set up those experiments manually. Here in PyCaret, you get it basically, right out the bat, because you turn that to true. And then the experiment name. In this case, we're going to say Kaggle, I already did an experiment, Kaggle credit card fraud 2. Let's do Kaggle credit card fraud 3. And it's going to set up another experiment. Okay. So any questions or any comments so far? Basically, this is the heart. Okay, this is the heart of PyCaret. After that, you'll see that the functions are very simple. But this is the one that you have to think. What are the options from all these options? What are the options that I'm going to be using? And sometimes you have to go back, right? You have to go back and say, okay, let me see. For example, there's a parameter for activating class imbalance. So there's some techniques that you can balance artificially those classes, okay, to get the same number. So you can activate that. We're not going to do it because it's going to, increase our impact in our machine. But we could do it. We could do different experiments. And the good thing about this is that when you go to MLflow, you're going to see all those experiments there. You just have to pick and choose what you want. Okay. Okay, so let's run this. Okay, nothing is going to happen yet. Don't worry, nothing's going to happen. Nothing's going to poof. go bye-bye. Okay, so this is just the setup. All right, so it gives us kind of a table with some of the inputs that we have been discussing. For example, session ID, which is the random state, the random number for the experiment 1, 2, 3, the target type, that is binary, very good. Okay, the data shape, transform data shape, the train set shape, 518, which is the 80%, right, that we're talking about. And then the transform test set, which is the validation from the training data set, which is 129, whatever. And numerical features, 37. So right now, we have a confirmation that the information that we are inputting is correct. Okay. And if you want to see a little bit more, you just go to the setup, right? CLF _1, which is the instantiation of that setup. Okay, and you'll see that is this kind of object, a classification experiment. Okay, so let's see. Okay, how we are in time. Okay, we're good. So how many models are we going to be running, in this experiment? Well, if you do CLF _1 models, these are all the models that you're going to be including in this experiment, right? Some of the models come from scikit-learn, others come from external libraries. For example, XGBoost. If you have installed in your environment XGBoost, it's going to capture it. If you have Light GBM, also. If you have CatBoost, also. Okay, at least those are the three main external algorithms that are not incorporated in scikit-learn that we can incorporate using PyCaret. But the other ones are from scikit-learn. Okay, so for this session, we're going to use then the compare models. So the compare models is the function that activates from the setup, it activates the running of each of these algorithms to the training set that we input. So one of the things that we're going to do is that we're going to sort the metric by AUC. We're not going to use accuracy here because accuracy is going to be very deceiving, especially for an imbalance class problem that we have. You can have a great, accuracy, 99%, whatever, but you are not hitting, okay, if your model is predicting if the fraudulent transaction is really fraudulent or not. And we're going to see that in something that is called recall and precision, which is the metrics that come from the confusion matrix. So the AUC combines that. It kind of combines the error under the curve, right? That it says that you have this metric that is combining the recall and precision. How well are you identifying those fraudulent transactions, and how well you are not identifying the transactions that are not fraudulent. Okay, if you go only through accuracy, it's just how many fraudulents were correct and how many non-fraudulents were correct, and that's just half of the story. All right.
And if I could just interject real quick in there, that is also particularly important when we're dealing with a highly imbalanced data set like we are with the fraud data.
Right. For example, when you saw the value counts, you saw that from all those transactions, 648,000, there are only 3,000. It's about 0.5%, okay, of the transactions that are fraudulent. So to capture that, we need basically an accuracy level greater than 99.5%. Okay, because if we hit 99.5%, that's basically throwing a coin, basically. Okay, because you can say, okay, every transaction is going to be non-fraudulent, and you could be 99.5% right. Is the 0.5% that is our goal to capture those? Okay, so we're going to exclude, because I already did some of the experiments here, and some of these algorithms take a long time. Okay, in fact, if you want to run everything, that I show you in the models, you need at least to give it an hour, okay? Because some of them, for example, KNN, support vector machines, GBC, which is the gradient boosting classifier that is provided by scikit-learn, they take a long time, okay? So I did already the work to extract that so we can have, you know, a better performance with the algorithms that we're choosing that we're not excluding, all right? Then we're going to select the best 3, okay? We're going to select the best 3, and the budget time is going to be 10 minutes, right? So let's see, let's run this, and let's see how we're doing. Okay, so it's starting to run, and the first model that is going to run is the logistic regression. Okay, the same baseline that we had in our previous session. Okay, and you already gave us, you know, some of the metrics. Okay, then it started then with the naive base, right? And it's going to give you the metrics. Then started with the decision tree classifier. It's going to give you the metrics, and then they're going to be ordered always by the AUC, by the one that we set here that we're going to sort. Okay. This should approximately take about, you know, when I did it last time, about 5 to 6 minutes. But as you can see, you get all the information that you need to make a selection of which are the best models right now with the default parameters. There's no hyperparameter tuning or anything here. It's just with the default parameters of each of these algorithms provided by scikit-learn or provided by that library. Okay. Okay, let me see who's still out there. Okay. Okay, good. It did much better. Apparently there was a cache somewhere. Because when I did it, you know, last time it took about 6 minutes. So there could be some cache, you know, there. So be careful. Be aware with it. Okay, so our first model, the best model that we have here, okay, I don't know if you can see it right now here, is this one, XGBoost, right? Kind of a surprise, right? Okay, no, it's not. Usually XGBoost, you know, works really well with you know, high dimensional data and also with classic balance. And the AUC is pretty good, right? It's 99.9979. And the measure that we want to really focus here is the recall and the precision. So for us that, you know, are not, you know, aware of those terms, okay, I did this, which is from the KD Nuggets, okay, and it explains what is a confusion matrix and what are the terms from the confusion matrix that are called precision and recall. So as you can see, this is the confusion matrix, right? This is all the tabulation versus the actual and the predicted values. So when the predicted values and the actual values are 0, both 0, then it goes to this, counts to this, you know, square. If they are 1 and 1, right, you know, fraudulent, it goes to the square, the true negatives and the true positives. Then we have the false positives and the false negatives. And that's what precision and recall brings to the table, okay? What happens in precision, what we're doing is getting all those true positives, right? The true positives here, but then we're going to divide it, the true positives, with the addition of the false positives, which is this quadrant. So it's going to give us a measure of how well our algorithm is predicting not only the true positives, but also minimizing the false positives. The same thing for the recall. The recall goes to the end of the true, you know, positives with the false negatives, with this one. Okay, so one brings the false positives, one brings the false negatives. Okay, so going back to here. Here we have the recall, and as you can see in the XGBoost, we have 0.3. In other words, of all those observations, 0.3% fall into the recall, and 0.95, which is better, fall into the precision. Compare it with logistic regression. That was our baseline of the previous session. even though we got accuracy of 0.994, we got an AUC of 0.8436, which is more or less. But then when you see the recall in terms of capturing, minimizing those false negatives and false positives, the model really is not good. Okay, you are getting 0.04, okay, and then 0.27. Definitively, we cannot use those measures, because what it's saying is that I have problems identifying the fraudulent transactions. Okay, in terms of, I'm saying that they're not fraudulent, and they are. All right. So, which are the best models? Let's continue here. And the best models, we said that we're going to select the first three, right? Which is the XGBoost, the CatBoost classifier, and the AdaBoost classifier. And these are the parameters for each of those classifiers. Okay. Then, if you want to go a little bit more in detail of each of the classifiers, because this is basically this is a pandas data frame. So you can slice from the rows, you can slice using the index. Okay, you can slice each one of these algorithms and get the parameters just by that. So let's say that we want to focus on the XGBoost. So we can say best models bracket, right? The bracket, and then 0. And it's going to give us this information, which is the same here. The only thing that here you get the 3 models, okay, at the same time. Here you get only the XGBoost and the parameters that were used. And as you can see very clearly, the parameters are basically the default parameters that you get when you run XGBoost. So now we can see that we can have some potential improvement if we hyperparameter, this model, okay, which is the best one. The same thing for the other models. The only thing that CatBoost, because CatBoost operates a little bit differently than the other ones, is kind of hidden, right? It has an object classifier. So it's something like the PyCaret classifier that we saw, okay? It's kind of an object. So it's kind of, hidden there. But the parameters are there, it's just that you need more, add more objects to it. And then the AdaBoost model. Okay, so, but right now we have an idea on how well those algorithms did with the training data set. And that's fine, because the training set is the one that we're using to create the, to create the model. What happens when we test this model with the test data set, the one that we're going to use as new data? So the first thing that we have to do is generate some predictions, right? Okay, so the function in PyCaret for generating predictions with a certain, with a certain model is a predict model. Okay, so when we go to predict model, it's going to generate those predictions, and you'll see them. We're going to use the XGBoost, the first model, which is the best model, and then you're going to see that we have already the test data frame here, but then at the end you can see that there are 2 columns that are added. The prediction label, this is the prediction, and then the prediction score also. Okay, so you can manipulate this, because the threshold usually is 0.5, right? But you can do some manipulation with that threshold to get, better results, especially for the recall and the prediction. But right now, we're going to set it just as default. So this is the prediction label. So now what we can do is add that information into the test data set, right? And we're going to call it the days data set. We're going to call it the test data frame predictions. All right. So we're going to do that. Okay. And now in that test predictions, right, we have the same data frame that we were, that we get with the predict model. but we got to now save into this object, test data for predictions. So now we can say, okay, let's try to plot what is called an ROC curve. The ROC curve, what it does is that it gives you, remember the precision and recall? It flips it backwards a little bit, and it gives you what is called specificity and sensitivity. But it's a measure also of false positives and false negatives. So the closer that curve is to the left and upper axis, close to the ones axis, then the model is doing a better job at discriminating against that binary outcome. So let's see how that model works, looks. Okay, so as you can see, this is the diagonal, which is 0.5. So if your model is around here, that means that is predicting almost by chance, your outcome. But here you see that the ROC is very close to 1, so it's a good thing. And the area under the curve, the maximum will be 1. So right now, the maximum that you have, at least for the test model, is 0.9674, which is good. It's very close to 1. But the ROC curve is kind of, it takes a little bit of imagination, to get some insight to it. Usually, what we do is that we use the confusion matrix, which is more intuition. It is more intuition of how well our model is predicting. So for PyCaret, we have the plot model, okay, function, the same function that we use for ROC curve, but then the plot is going to be the confusion matrix, and we're going to do it as a percentage. Okay, so this is the confusion matrix, and as you can see, we got 100% in that run. We got 100% of predicted class that is 0, that is non-fraudulent, and the true class that is 0, okay, which is the majority class. Here, what happened is that from the fraudulent transactions, the algorithm could predict truly negatives, truly positive, sorry, we could predict 84% of those instances. But then 16% were predicted as no fraudulent, as 0, but they were truly fraudulent transactions. Okay, and that could be a concern, right? Because right now, our concern is trying to predict the model. When a new transaction comes, the model should predict very accurately if that transaction is fraudulent or not. If it's fraudulent and the algorithm is not predicting it, then you have a problem, because then it will go in the non-fraudulent bin, and no action probably will be taken. Okay, try to think about this in a in an organization, in a bank, for example. Then 16% of those are going to be set to the non-fraudulent, which are fraudulent. So what happens? Let's say a week passed, right? A week passed, and the client says, "Hey, I got this fraudulent transaction. What happened? What didn't you detect it?" And then you'll get angry customers. Probably the insurance will have to, get involved, because then, if it's not an issue with the customer, it's an issue with the organization. So they have to reimburse, etc. So those things come from this very small percentage, but very, very worrisome percentage. Okay. Are there any questions here? I see some in the chat. Okay.
I've been handling a few side questions in the chat, so you're good to go.
Okay.
And just a heads up that we're about 8 minutes to the top of the hour. So
okay, good. Yeah, at least I'm going to commit this script to the GitHub. Okay, so you can play around with it and do some experiments of your own, because some of this, for example, the hyperparameter tuning that I did with the XGBoost, which was the top model, it took about 60 minutes, to do it, and my machine is not that, that clumsy. Okay, so then remember the Seaborn library that I was talking about, the wrapper of the matplotlib? Well, here we're going to use it to get another, visualization of the confusion matrix. Okay. And here, what you can see here, right, is not only the percentages, but the actual, values from where the percentages are coming from. Okay. So as you can see, this 0 is not really 0. It's 0.002, etc. So in this one, you see that in the, let me see if it's the same one. Yeah, it's the same one. Okay. So you see that the predicted class here, even though it says that it's 84, probably coming from the training data set, when you use the test data set, you see that it's lower than the 84 that we had. It only, classifies as true negative, true positives, 0.42, 43%. So when the new data is coming, you are getting more transactions that are fraudulent in the non-fraudulent bin. Okay, and that's something that with the hyperparameter tuning you can improve. You're not going to get it perfect. Okay, you're not going to get it perfect, but at least try to get as perfect as we can. All right. So let me see if I can wrap this up. Just explain more or less, the other functions that we're doing. So the cat boost was the second model. And it's always good, to check the second model so we can do the predictions, can do the plotting, etc. There was not that great, improvement from the cat boost, as I remember. Let me see if I can put you there, the confusion matrix really quick. Okay, so for the training data was 83% and 17%. And if you apply the test data, but maybe it will be a little bit more, there. Then when you have already, your model selected, okay, we're going to with the XGBoost, right? We feel comfortable that that's the model that we're going to do. What you have to do is that we have to finalize the model. What I mean is that when I finalize the model, is that I'm going to refit the whole training data set. Remember that we're taking only 8%. We're going to refit. We're going to apply that XGBoost with the parameters that are with the whole training data set. And that's what is called finalize. Okay. We do this because we want to see if there is a change, okay, which within the 80% or the 100% that we have, if we see if there's a degradation or something. Then after that, we're going to evaluate the model, we're going to plot the AUC, etc. There was not that big change, okay? But then you have all kinds of plots here, and that's one of the best, things that PyCaret, can do, because usually you have to go to scikit-learn and then check, okay, which is the configuration of this function to get an ROC, to get a gain plot, to get a feature importance, etc. So sometimes it's not that uniform. PyCaret takes care of that. And one of the things that take care is, for example, the plot feature importance. It's just another plot, right? Plot model, you get the best models, bracket 0, right? The best models, and then plot feature, okay? And it gives you the top 10 features that model used to get the predictions. And as you can see, the grocery POS sale is right there at the top. Then the gas transport, the CC number. Apparently, some credit card numbers are more prone to fraud than others. The amount, grocery net, we expected that. The transaction hour that we saw, that some fraudulent transactions only appear in certain hours of the day, especially during the morning. Category home, shop net, and all that. So it gives you already that information out of the bat. Okay, and you can keep going on and on. You have the hyperparameter tuning. Remember, I said a comment here. Long running script, 60 minutes. So I warn you. If you have, I have 16 cores here in my computer. It's a Ryzen 7. If you have less than that, it will take more time, okay? Because it's doing it in parallel, etc. So be warned. Then once you hypertune it, then you can then do exactly the same procedure, the refitting of the finalized model, generate the predictions, and basically that's your final model for that one. But then PyCaret gives you the tools to do ensembling. Okay, so you can take those three models, hyper-tuning each one by them, and then stack them together. And probably that will give you much better performance than only one model. All right. So that's basically my spiel. I hope you like it and you feel motivated to try a couple of these things.
And you are like, and then right on time, just 1 minute to go.
There you go.
Perfect timing. We will post this video, this session up on YouTube, and we posted that link in the chat earlier to our YouTube channel. You can find the rest of the videos from prior sessions on this series up there. And as soon as we get this one processed and we can upload it, it'll be out there probably later today, maybe tomorrow. Okay. Anybody have any final questions or thoughts they want to bring up before we wrap up? And I'll go ahead and stop the recording, so if people don't want to be on tape, they don't have to be.